Okay, so this is the Avogadro program. We can make molecules here. Let's look at a random molecule that has a tetrahedral shape. So carbon tetrabromide, for example. Here's how we make it. We go to the little pencil guy up here, and then we make sure that our adjust hydrogens is unchecked, and we pick the type of element we want to make. So we want to put down an atom of carbon, and we just click right over here in the screen. And tetrabromide means there's 4 bromines. So I'm going to click to make a bromine, and we want to bond 4 of them to the central carbon. So I'm going to click and drag to make bonds. And here's our last bromine. So I just kind of put the bromines on at random positions. But this Avogadro program can tell us what this molecule should look like. Here's how to do that. We're going to go click on the E here. This is for energy minimization. So basically it optimizes the geometry of the molecule. So it basically gives it the right shape. And then we just hit start, and it may or may not make it into the right shape. We know that this is supposed to be a tetrahedral molecule, but what it has made here is a square planar molecule. So the only reason this is not right, and the only reason it would make a square planar molecule is if, I just fixed it. So I kind of gave it a nudge and pulled an atom away from but the only reason it would want to be square planar is if there were electron pairs that were pushing these atoms into a plane. But here is the tetrahedral geometry, so you can kind of just click and drag and kind of see what that molecule looks like in 3 dimensions. Okay, let's see what ammonia looks like now, which is a trigonal pyramidal shaped molecule. So we're just going to delete our carbon tetrabromide by hitting the arrow up here, dragging to select everything, and hitting delete. Okay, now we can go back to making another molecule. I'm going to hit pencil and make a ammonia, which is a nitrogen with hydrogen. 3 hydrogens. So let's see how the program does when it tries to fix the geometry of this ammonia. Not too well again. It tends to like to make molecules planar that shouldn't be. So this would be a trigonal planar geometry. And again, I'm going to try to fix it by just dragging one of these atoms, giving it a little nudge. There we go. Now it looks trigonal pyramidal. So it's exactly like the carbon tetrabromide, but instead of a 4th atom on top here, there's an electron pair on top that's pushing the 3 hydrogens down. Okay, a quick recap. First we saw a tetrahedral shaped molecule, carbon tetrabromide, then we saw trigonal pyramidal shaped molecule, ammonia, and just for fun, let's see a trigonal bipyramidal shaped molecule here. So this will be like 2 triangular pyramids. So we're going to go to the pencil. Let's see how Avogadro does with phosphorus pentafluoride. I'm going to bond I'm going to bond 5 fluorines to a central phosphorus. I'm going to let Avogadro try to fix the shape. Oh, do you see that? It's doing some weird stuff. For a minute, I think 2 of the fluorines overlapped and were in the same place. But Avogadro seems to have gotten the hang of it and fixed it. So there's our trigonal bipyramidal molecule. See, there's a kind of a pyramid on top here and an upside down pyramid on the bottom. Pyramid on top, pyramid on bottom.